don't need to derive 6. That's only for the graph at the start. But you can draw the graph in Excel.
No, the calculation is...
I don't know how to draw it in Excel. Watch the video.
I'll show you. It's really, really easy to make graphs in Excel, and I'm going to show you in 1 minute how to do it, because it's not like we haven't done it in maths and physics before. So while that's just loading, let me write down what we're looking at: proven trigonometric identities. Right. Did I pick? I did pick it, didn't I? Right, well, while it's loading, I'll give you an example of what I mean. So, for this lesson, all it's about proving stuff. Using rules that you have. So, actually, before I do an example, let me show you this here. So, let's say in a graph like, I want to plot e to the minus x squared from minus 3 to 3. So, here's the x, here's the y, here we start at minus 3, and then we'll go up in, I don't know, 0.25. So minus 2.75, okay, let's go all the way up to 3. And then here is the y, which equals exponential of x squared with a minus. Okay. E to the... I don't think I quite got the minus part there. Yeah, that's better. What am I doing? Let's copy it down. Right, so I've got the x and y's, and then I shall make the graph. Insert chart. So you don't need derive. You don't need anything fancy. You can just use Excel. I'll do this one. I'll connect the dots.
But you need it for the calculation.
No, you don't.
Okay.
I'm clear, right? You don't need derive to do this assignment. You can do it entirely in Excel. Entirely.
Normal graph.
Yeah. Not a fancy graph, a normal graph. So what's on the x-axis? X. What's on the y-axis? Y. What's the title? My stupid graph. Wow, that was so difficult. It took me like 1 minute to do. You don't need anything fancy. You can do this in Excel. Look, and then let me see. So that's a triangle. The base is 4 units long. Half the base would be 2. The height is 1. So the area of this is about 2.
One thing.
Yes.
If we try to, the thing we have to guess in the first part.
Guess?
The area, not the guess.
Oh yeah, estimate.
Estimate.
Yes.
Right. So we can do it with making lines with a pencil.
Yeah.
Yeah, but just draw a triangle.
Or we can draw it with a pencil or something.
Oh no, I know what you're saying. Yeah, no, I want you to copy this into paint and draw the lines on it. Yeah, not using a pencil. Is this what you mean? Yeah. Okay. Dude, what is wrong with people? I am speaking English, haven't I?
Is it real pencil or pencil on the Microsoft Word?
Wow, what a totally different age we live in. Yeah. Sorry, when I say pencil, I mean pencil. I'm sorry if that confuses you. Pencil, real pencil, okay? When I say pencil, I do not mean digital Microsoft pencil, okay? Are you clear?
Yeah.
So I told Fahad he can't use his pencil, but he can use his digital Microsoft Paint pencil. Yes? Yes?
Okay,
right. Try not to be ridiculous. It's difficult, I know, but try not. Okay, so for this lesson what we're doing is proving trigonometric identities. So there's there are three strategies you can take. So strategy one is you start on the left and try to arrive to what's on the right.
Okay.
Strategy two is you start at the right and try to arrive at what's on the left. Or strategy three is you start with both and try to reach some statement which is obviously true, whatever that might be. So I'll
First
Mhm.
take this right, take.
no, it's like first strategy is you start at the left and try to end up with sex squared. Second,
Always.
well, sex squared because it's sex squared here,
Okay.
yeah. And here, the second strategy might be to start with sex squared and try to show that it's equal to 1 plus tan squared.
Okay.
Or the next strategy is to start with both and change them until you end up with something that's true, clearly true. There's not one right or wrong way to do this, as long as you can prove it, but there are easier ways and more difficult ways. So for something like this, I feel like starting with both is the best thing to do.
Because of you suggesting one.
My suggest
Specific reason.
because it kind of looks like a rule I already have, which is sine squared plus cos squared equals 1. So I feel like I could manipulate it into a rule I already have, which is true. This is why. Because it looks similar to a rule I have. So tan squared I know is sine squared over cos squared. And sec squared is 1 over cos squared. So what do I do next, do you think?
Multiply
Multiply
by
by
cos
cos.
Multiply by cos squared, and I get cos squared plus sine squared equals 1. Is this true?
Sure.
Yeah. So this ends the proof.
Oh, that was easy.
Well, it was the first one. Okay. Let's say I had something like this. Prove that sine,
Which one?
this is actually D, that was actually A, and this is actually D. Prove that sine pi over 2 minus x equals cos x. Your thoughts on what do you think or feel would be the best strategy here?
This is the wrong way. Because,
Z?
yeah. You switch the sign and cos.
No.
No, did not. Oh, but I wrote the wrong number. I'm actually doing C.
Oh, okay.
Yeah.
Then
That's C. Right, your thoughts?
Divide by.
No. My question firstly is start at the left, start at the right, or start with both?
Both.
Both.
Wrong.
Left.
Start at the left. Because I have a compound angle rule I can use on the left. Hopefully I can simplify it to cos. So we start with sine pi over 2 minus x. That is sine A cos B minus sine B cos A. Sine pi over 2 is 1. Cos pi over 2 is 0. This is 1 cos x, which is cos x, minus 0, which is cos x.
Sin pi over 2 is 1.
It is.
How will you show me? That's right.
Again, there's not really one rule to tell you if you should start with the left or start with the right. But I can't really start at the right here because there's nothing I can do with cos. Cos is just cos. I mean, what can I do with cos? Nothing. It's just cos. Whereas at least on the left I can use compound angle rule because it's a compound angle. So you could start with the right, but that would be very difficult.
Sin x is 0.
No? 0 sin x. Cos.
Cos.
Proceed. Yes? Okay, next one now. Right, so let's say we want to prove something like, this is f. Sine squared x equals 1 minus cos 2x over 2. So, if I want to try and prove that this is true for all values of x, what should I do? Left, right, both?
Left, right.
Both.
And the answer is on the right. Because on the left, well, on the left you would have sine squared, which you can change into 1 minus cos squared, but that's not too helpful. On the right though, you have cos 2x, which you have a formula for. So let's start at the right. 1 minus cos 2x over 2. That equals 1 minus, now the formula for cos 2x is cos squared x minus sine squared x all over 2. But I could change 1 here into sine squared x plus cos squared x minus cos squared x
What did you
plus
change?
sine squared x, the 1.
The one where?
There's only one there.
Did you change it?
You changed it, then what now happened to the cos 2x?
What happened to the cos 2x? Whoa, we have to go back to the start. Cos 2x is a double angle. I used the formula I gave you last week for the cos 2x, which you should remember if you were doing the homework. That's right, no comment.
The formula is...
Okay, stop talking now. Mister, I'm going to get an A.
You'll be surprised.
I won't be. What do you need for maths? Okay, so what happens here? Well, those cos squareds cancel, and you get 2 sine squared x over 2, which is sine squared x. Okay. Can I continue? Right, let me give you one to try, and then I'll do it.
Which one?
I'll write it down here. I want to see which one would be good. You could try I. I would be good to try. Try I. Where's your book? So no physics homework, no maths book, not in class this
They
morning.
come together, Stephen.
Sit beside someone with a book.
Yeah.
Can I multiply this with 2?
Multiply how?
2.
What do you mean?
So you can cross this.
Oh my goodness. I will pretend I didn't hear that.
Seriously?
Yeah, it's that bad. No, you cannot do that.
Do what?
No.
What did you say?
No. What side? Okie doke. Any luck?
Yes.
You proved it? So, left, right, both.
Right.
You went for right. Cool. So you use compound angle. Product?
Yes.
Oh yeah, I suppose so. I'm going to start at the left for kicks. So, I have sine x plus sine y. We're groovy?
Mm-hmm.
So what the heck can I do here? Well, I can do this. No. Wait until I show you, then you can be shocked, okay? We'll try that again now. I can do this. Sine x is the same as sine x over 2 plus x over 2. There you go. Plus sine y over 2 plus y over 2.
Should we change it to the component?
So x is a half x plus a half x. Y is a half y plus a half y. I can use compound angles now. Sine A plus B. That's sine A cos B plus sine, well, you know the story, sine B cos A. And then it'll be the same thing, sine y over 2 cos y over 2 plus sine y over 2 cos y over 2. Isn't that it? No, this won't work. Stop!
Mm-hmm.
This won't work.
You're getting confused.
Stop! It won't work. Hit foot on the brakes. Or maybe it will.
If you add all of this, see how many you can get.
You know what? Maybe it will. Because
Or sine.
what I'll do is I'll put this one beside this one. and I'll put this one beside this one. So I'll just rewrite it as sine x over 2 cos x over 2
Is y equal to? Okay.
now it won't work, I'll have to do it the KJ way.
Because you already have the compound one.
Yeah, no, I didn't want to do it his way, but I'll have to. It's alright. I'm willing to accept this. Okay. Huh? I just didn't want to do it his way. This is how I feel right now. So 2 sine x, okay. Cos x minus y over 2. So this would be 2 sine x over 2 plus y over 2 cos x over 2 minus y over 2. That's what you did, isn't it? Or you did something else? Oh no, you did it as product, but I haven't given you a rule for product.
You have.
I have?
Yes.
Kind of a proof of the rule for product.
Yes.
Yeah. Do you want to do it with product? No, let's not do it with product, because then that would be doing it your way. You can still do it a different way. Right, so this would be 2, and then we'll have 2 brackets, and this would be sine. Now to save space, I'm just going to write sx to mean sine x over 2. So it's sine a, what's after it? This is sine a plus b.
Sin x over 2?
Yeah, sine x over 2 times, come on, this is sine a plus b. So what's the formula for sine a plus b? Sine a cos b. I think I can fit it in. I'll just write s for sine. Sine a cos b. Yes, Tech, can go on. Sine b cos a. And then this one here is cos a minus b. So that's cos a cos b, very good. Plus sine a,
The plus of the two of them.
because there is for the formulas.
For both minus
Yeah,
and
yeah.
plus.
This one has a plus and this one has a plus. Alright, so let's multiply it. So this would be 2.
No, a minus sin a minus b has a minus.
But this is sine a plus b.
Then, oh, of course.
Continue?
Yeah.
Yeah, thank you. So this is sine x over 2 cos y over 2 times cos x over 2 cos y over 2. So it's going to get quite large, so let me make some space. Sine x over 2 cos y over 2 times cos x over 2 cos y over 2. What's next? Plus sine x over 2 cos y over 2 times sine x over 2 plus cos y over 2. Oh, this is looking terrible. Plus sine y over 2 cos x over 2 cos x over 2 cos y over 2. Not feeling so well. Plus sine y over 2 cos x over 2 sine x over 2 sine y over 2. Anything we can do to simplify? Sine x over 2 sine x over 2 cos y over 2, no, cos y over 2 there, cos y over 2
You need to.
hang on KJ, I can get out this pickle. Yeah. Oh, lol. Right. Fine. We'll do this this way I didn't want to do it. For some reason I don't understand why. Right, 2 sine x plus y over 2 cos x minus y over 2. So you know that sine a plus b is sine a cos b plus sine b cos a, and sine a minus b is sine a cos b minus sine b cos a. So when you add them together, you get 2 sine a cos b equals sine a plus b plus sine a minus b. So your question here can be written as 2 sine a cos b. If you call this here a, and if you call this here b. So the rule I just proved says that this should equal sine a plus b plus sine a minus b. So that would be sine x plus y over 2 plus x minus y over 2 plus sine x plus y over 2 minus x minus y over 2. That would be sine 2x over 2 plus sine 2y over 2, which would be sine stinking x plus sine stinking y. I don't know, I just didn't want to do it that way. And I can't even explain why I didn't want to do it that way. Okay, have a try of m. I think it's because I'm hungry. And it's making me go a little bit crazy right now.
And you can smell the fries.
I can smell something smells good. No, there's someone's having chips.
Yeah.
Smells good. Bit of cheese and garlic sauce on it maybe. Right, try M.
That's a plus b?
Probably.
Sine.
So-
No, I can't see.
Here, this one,
No, the other one.
A minus B.
The same.
M? Not quite.
Look, I think I need to write all the numbers on one page.
Same for the previous question, I multiplied at first by 4. Correct? So
No. Multiply what by 4?
everything by 4.
No.
I can get rid of the fraction.
No. That's wrong for 2 reasons. Number 1, you can't do that because this angle is trapped in the sine and the cos. Fahad already asked me that. So you can't multiply by 2. And secondly, you shouldn't multiply by 4, you only need to multiply by 2.
I need to multiply by 4
Why?
to get rid of the 2.
But there's only 2 in the denominator, you need to multiply by 2.
Which one?
The one we just did.
There's 4.
No, no, what
No. Firstly,
Which one you're doing?
now hang on a second.
Okay.
This here, we can't multiply by 2 because they don't cancel. And anyways, if we could cancel it, we wouldn't use 4, we would use, oh yeah, no, it would be 4. You're true, it's 4. So we can't do this. If we could, it would be 4.
Why? Why can't do it?
Because if I have sine x over 2, that 2 is not free. It's in the sign. Like for example, could you cancel the 2 would that 2 cancel that 2?
No,
Why not?
because like first of all it's under the root.
It's under the root in a sign in a log.
Sign
Yeah, well the same reason here. It's in a sign.
Which one you're doing?
M.
Okay.
Thank you.
You did it? Good job. So should you start at the left or the right, Tekken?
Right.
Very good. So you have a half cos x minus y minus cos x plus y. That's the one we're doing, isn't it? Yep.
Yes.
So we can use compound angle. This would be cos x cos y plus sine x sine y minus cos x cos y minus minus, no hang on, there's going to be plus here. That's a plus there. This plus will make a minus, but that minus there will be a plus sine x sine y. Yeah. This one here will cancel with that one there. So you'll be left with a half 2 sine x sine y. Sine x sine y.
Wow.
I'll do one more, then I'll let you try for a minute. So, come on KJ. You'll get your chips after class. Continue. Okay. So, have a look at T. Right, so let's have a look at T. So should we start at the left or at the right?
The
Left.
Or both? I'm going to start with the left. Sine 3x. What can I do here? That's sine,
X plus 2x.
yeah, 2x plus x. Which is sine A cos B plus sine B cos A. But sine 2x, we have a formula for. What's sine 2x? 2 sine x cos x cos x plus sine x, and then the formula for cos 2x is cos squared x minus sine squared x. So now we have 2 sine x cos squared x plus sine x cos squared x minus sine cubed x. So that would be 3 sine x cos squared x minus sine cubed x. What's the formula for cos squared?
1 minus sine squared x.
1 minus sine squared x. So this would be 3 sine x minus 3 sine cubed x minus sine cubed x. So that would be minus 4 sine cubed x plus 3 sine x.
It's 1 minus?
This here,
No, in the right hand.
this here's a 1 minus.
Why is that 1 sine cubed x?
Which line?
Okay.
Got that? Did you write that down?
Yes.
Two copies.
Hmm? Two copies. One for exams and
Tuesday.
Okay. So, I want you trying these for a few minutes, and then we'll come back for the last topic on the further trigonometry, which is good. Then we're on to vectors when we come back after the break. More advanced vectors than what we do in physics, much more advanced.
how many lectures we need after the break? Or how many hours?
There is about 20 something hours.
So we have time to for revision?
Oh yeah. My goal with the maths and with the physics is to finish end of
April?
April. So then we can revise in May.
We have 20 days, right?
Won't be enough for some of you. Just saying. You should need to be doing your revision now. Okay. Can you try these for a few minutes? 5 or 10 minutes while your teacher gets some much needed coffee. Yeah? Then the next lesson, page 62, this last lesson is a bit tricky, okay? So I'll be back in a minute.